Welcome you all. Myself Nagarajan, Assistant Professor in Department of ECE at Rohini College of Engineering and Technology. In this video, we will see about the AES algorithm, that is Advanced Encryption Standard in the networks and security. So in Advanced Encryption Standard, on completion of this video, the student will be able to understand about the DS algorithm and AES algorithm and also a RSA algorithm. So Advanced Encryption Standard, that is first of all we need to understand the introductions, that is the cipher principles. So it has two types of ciphers there. One is a stream cipher and another one is a block cipher. In a stream cipher is one that encrypts a digital data stream 1 bit or 1 byte at a time. Example Vigenère cipher and Vernam cipher, and one suitable logic used for a stream cipher is the XOR logic. It is a quite simple and produce an output of 1 only if one input is 0 and other one is 1. The output is 0 if both the inputs are 0, if both the inputs are 1. So block cipher is one in which block of plain text is treated as a whole and used to produce a ciphertext block of equal length. Block size may be 64 or 128 bits. It is called as a Heisel cipher, DES algorithm and AES algorithm. Let us start the AES, Advanced Encryption Standard. So Advanced Encryption Standard was published by NIST, National Institute of Standards and Technology in 2001. AES is a symmetric block cipher processed by a Regental. So AES have the following characteristics: resistance against all known attacks, speed and code compactness on a wide of platforms, design simplicity. The input to the encryption and decryption algorithm is a single 128-bit block. In FIPS 197, this block is depicted as a square matrix of bytes, data block of 4 columns of 4 bytes. So in this block, it is copied into a state array which is modified at each stage as the encryption or decryption. After the final stage, the state is copied to an output matrix. So already we discussed that is a AES is a 128 key is depicted as a square matrix of bytes. So we have a 4 transformation are used in the AES algorithm, one of the permutation and 3 substitutions. So 4 transformation are used, one of permutation and 3 substitution. First one is a byte substitution, one S box is used in every byte, and next second one is a shift rows, permute bytes between groups and columns, and third one is a mixed columns. Substitute using matrix multiplies of groups and except 10th round. And then finally that is the add round key, XOR state with the key material. So this is a advanced encryption standard diagram. This is we have inserted the plain text is given to a add round key. The add round key is consisting of a 2 input. One is a plain text and another one is a key from the 0 to 3. And is the output of the add round key is given to a substitute bytes, and substitute bytes is given to a shift rows. These are the round 1. These are under the round 1. So substitute bytes and then shift rows and then mixed columns and then add round key. So these are round 1. We have a 10 round for AES algorithm. So after completion of a 10 rounds, we get a that is a plain text is converted into a ciphertext. Similarly, this is for encryption. Similarly, we are using these in the decryption side. So this is a advanced encryption standard state diagram. That is a state, subbytes and state, shift rows, then state, mixed columns, state, and then we have a 4 transformations. So like that we have S box, then shift rows, then mixed columns, then state, add round key, then finally we get that is a state. Byte substitutions. So in the byte substitution, that the forward substitute byte transformation called a subbyte is a simple table lookup tables. A is defined as 16 cross 16. matrix of byte values called as a X box. So contains a permutation of all possible 256 8 bit values. So this is a X box. X box is substitute byte. And next one is a shift rows. Shift the row in left side. And next one is a mix columns. So I hope that all of you understood about the AES algorithm. Dear student, thank you.